So what I'm going to do now is to just go over the Farmer Ghana Limited story. Okay. So you have already come across the situation here. Here is the situation. Anytime you are doing a linear programming problem, okay, you will have to write the objective function. First thing you want to do is to determine the decision variable. Okay, you determine the decision variable, or you write the decision variable. Okay. The second thing you want to do is to formulate the objective function. Okay, the objective function. And then you will formulate the constraints. Okay, and then you will solve. You're going to do that solution graphically. So we're going to do the whole process graphically. So I know the entire story. So I'm going to tell you the entire story. In the process of telling the entire story, I tell you the answer. So the first thing is to identify the decision variable. In the story preamble, the decision variable was that Farmer Ghana Limited has to produce Fan Yogo and Fan Choco. So the decision variable, okay, was for you to represent X1 by something and then X2 by something. Now, the problem is that sometimes when people want to represent the X1, they just say X1 Fan Yogo, X2 Fan Choco. That's not correct. You want to bring the unit of measurement. Farmer Ghana Limited, the Fan Yogo is measured in sachet, and the Fan Choco is measured in sachet. So you have to say that X1 is the number of sachets, okay, of Fan Yogo to produce. Okay, and I want you to be writing this, because whilst you are writing this, it's going to help. The number of sachets of Fan Yogo to produce. Whereas the X2 will be the number of sachets of Fan Choco to produce. Okay, so it's very important to recognize this, understand this, and apply this anytime you are dealing with any of these things. It's very important. Okay, if you don't get it here, you let me know. If you don't get it here, you let me know now. If you are not clear with this, you let me know. Okay, so learn how to formulate, because I normally will ask you all of this in an exam, like what are the decision variables, or define the decision variables. You got to be able to tell me. And if you write the decision variables without adding the unit of measurement, wahala. So you have to add a unit of measurement. In this case, and in this context, the unit of measurement is a number of sachets. The number of sachets. So that's the first thing. The second thing is to formulate the objective function. Now, in the story that we were given, we were told something about objective function. Anytime you are formulating the objective function, you bring it the letter Z. Z is the objective function. Z can be revenue. Z can be profit. Z can be cost. Z can be distance. And you always write it as Z max or Z min. Max, when you have identified that, is a maximization. Now, according to the story, which I know you all have in front of you, the story said that Farmer Ghana Limited want to know how many sachets of Fan Yogo and Fan Choco to produce in order to maximize profit. Okay. So the Z function is supposed to be Z max as a subscript. Then you make it equal to, and I'm giving you the general approach. The general approach is that CXI plus CJ, okay, XJ. That is as many of the variables that you are dealing with, okay, up to CN XN. In other words, as many of the decision variables as there are, each one must have a C coefficient. The C, ladies and gentlemen, the C is the coefficient. Another name for the C is the coefficient. It is a per unit something, per unit profit, per unit cost, per unit revenue, per unit distance, per unit something. And it is being multiplied by the decision variable. Okay. So each of the coefficients is a number. Okay, it is a number. Okay, and it's multiplying. So the goal is that now that per unit means that it is for a single one of the decision variable you are dealing with, one of them. Now, for our purpose and for this course, we were told that this company is producing how many sachets of Fanyogo? Of course, Fanyogo is X1. We're told that they are producing 40 units of Fanyogo and 50 units, you see, per unit of Fanchogo. Of course, if there was another one like Fan Ice, we would have had a coefficient for it, and then that would be X3. Okay. So this is how you formulate the objective function. After you formulated the objective function, then you are now good to go forward. Now, if you don't understand how I formulated this objective function, you just raise your hand and I'll just clarify it. Okay. Now, after you've written the objective function, you now bring the terminology subject to, because you've already learned that you cannot maximize profit alone because you are limited, you are restricted, you are constrained by some constraints. And so you got to be able to formulate the constraints. Now, the way you formulate the constraint is very important, ladies and gentlemen. There is an approach you should always follow whenever you are formulating the constraint. The first one is to know that we have the left-hand side of the constraint, we have a symbol or a sign, and then we have the right-hand side of the constraint. Okay. Now, the left-hand side of the constraint is usually called usage. Usage. Then you have your sign, and then you have the right-hand side of the constraint. Sorry, the right-hand side of the constraint is known as available. Available. I'll explain each one of them. Available. Now, usage deals with the number of quantities you actually used of those resources. Okay. Now, please note that there are three kinds of resources, or there are three kinds of constraints. Okay. There are three constraints that you should have in mind. The first one is known as resource constraint. Resource constraint. Then we have the mixed constraint. And then we have another constraint well known as the non-negativity constraint. Non-negativity constraint. Now, these constraints are what might be given to you whenever you are doing the formulation. Okay. Now, you'll be told of the available constraint, the available resource constraint that is there. So that is what will go on the right-hand side. So on the right-hand side is the available. Now, the word available means something. It means that that is all there are. That is all there are. You can use all of that, or you can use less of that, but you can't use more than what is available. You can't do that mistake because the resources are limited. Resources are limited. And because resources are limited, you are limited regarding how much, labor hours you can use. And when you look at the story very carefully, you will be told that the hours of labor that is available is how many? Who can tell me? Type it there for me. The hours of labor available is what? What was the hours of labor available? Just type it there in the chat for me. Okay, this one's saying it will be true something. Okay. What is the hours of labor available? type some because I'm recording this and I want to use this to give marks to those that type things. Okay. The hours of labor available is 40. Okay. So you will now, on the right-hand side, you're going to put the number 40 hours. 40 hours. And then the gallons of milk. So we are talking about labor constraints. And then we are talking about milk constraints. We're told that the gallons of milk available is also how many? Gallons. Excellent, Victoria. So that is 120 gallons. 120 gallons. Now, because these things are available and you cannot use more than what is available, what sign do you think should be used for this? What sign should be? What mathematical symbol should be used to indicate that you can't use more than what is available? You can use what is available, or you can use less of what is. Susanna, that answer is wrong. Okay. Vincent, your answer is correct because it cannot be less than, it has to be less than or equal to. So the less than or equal to is what you are going to write for the sign. But I want you to understand what the less than or equal to means. What is the equal to part? The equal to part is when you have used everything. Everything. You see, the usage is on the left-hand side. So if you use all of the existing hours of labor, then the symbol becomes equal to. But if you don't use all of the available resources, then it becomes what? It becomes less than. That is why it's less than or equal to. Now go to the story again. Go to the story. See, I'm not the one going to show you the story. By now you should have your story in front of you. Okay. The story said that in order to 1 hour of labor time was used to produce fine yogo, and 2 hours was used to produce fine chocolate. So watch, 1 hour was used to produce fine yogo. And we know that in the X and the Y formulation, fine yogo comes first and fine chocolate comes second. 1 hour was used to produce fine yogo, and then another 1 hour, 2 hours was used to produce fine chocolate. So the usage will be 1x1, that is 1 hour. I'm writing the 1 for a reason. And then for the choco, you will have 2x2. Okay, you have 2x2. And then we're told that for the milk, 4 gallons of milk was used to produce the choco. 4 gallons of milk, okay, was used to produce choco. And 3 gallons of milk was used to produce fine choco. So fine yogo has 4 gallons utilized. Okay. So that's how you do the formulation. And then you bring your non-negativity constraint, which is what? Which is x1 and x2. That is your decision variables should be 0 or positive. Okay. It's not like they should be just positive, but they should be 0, because sometimes you will not produce anything. Some people start company, okay, and in the first year they produce nothing. You know, it's all loss. So the 0 part of the non-negativity is reasonable. So on the basis of this, we can now rewrite our entire formulation. Our entire formulation becomes Z max equal to 40x1 plus 50x2. See, now when you see it like this, you're not afraid because you know where it came from. Okay, subject to, then you have your first constraint, which is x1 or 1x1 plus 2x2 less or equal to 40. Then 4x1 plus 3x2 less or equal to 120. Then your non-negativity constraint. Okay, so this is your whole situation. Now the question is that we need to be able to find the optimal solution, but you can't find the optimal solution unless you have the optimal feasible solution. Okay, So in the feasible solution that you guys have learned already, I'm just recapitulating. You have learned that you have to plot your X and then your Y. X1 on the X-axis, X2 on the Y-axis. And you're going to plot them. How do you do the plotting? How do you do it? What you do is that you first deal with the constraint. So you deal with the labor constraint and then go and deal with the milk constraint. You start all the plotting with the constraint. Follow me here, follow me here, follow me. Please, if you are getting value, type value. If you are getting value, type value, because I need to be sure that you are on the same vicinity with me. Okay? If you are getting value, type V. If you are getting it, say yes, I'm getting it. If you are not getting it, say no, 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 no. You are getting it, say yes, 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 yes. I need to be sure. And you know, whilst you are typing, somebody is saying that, why do I have to type? Now imagine that typing is what is going to give you an A, you will type, or $1 million, you type. All right. Now, once you've done that, now let's deal with the first constraint. The first constraint is X1 plus 2X2 equal to 40. Why am I using equal to? Because at least I'm using the maximum value, okay? Because everything is below it, okay? So the equal to is going to be the line. Below it, which is the less than, is going to be the space below the line. Now, this is an equation of a line. In case you've forgotten an equation of a line is y is equal to mx plus c. Okay, that's the equation of a line. The c is the number, which in this case is the 40. Okay. And then the y and the x are the x1 and the x2 here. Equation of a line, you just need 2 points to draw an equation of a line. Okay. So all you would tell yourself is that, let's assume that, that's what you do. You make an assumption here. Okay. You say that assuming that this x2 is 0. Okay. Assuming x2 is 0 here. What is going to be x1? Who can tell me? Assuming x2 is 0, what is x1? Assuming x2 is 0, what is x1? Okay. If x2 is 0, then x1 is 40 somewhat. Good answer. Okay. If x2 is 0, then x1 is 40. So you will know that the coordinates that you need, the first one is 40. Okay. Now, if x1 is 0, what is x2? If x1 is 0, what is x2? If x1 is 0, Vincent, good. That is 20, okay? So you are going to plot 40 on the x-axis and then 20 on the y-axis. So 40 on the x-axis. So 40 is the x1. So when you look at the x1, just identify somewhere here and call it 40, okay? And all you need are 2 points. And then go to the x2, that's the second number. Identify somewhere there and call it 20. And all you are going to do now is to join the two lines together. So you take the 40, you join it to this. Now you've been able to plot that line. Now you go to the second constraint. So if I were to name this constraint, okay, if I were to label this constraint, it is going to be x1 plus 2x2, okay, less or equal to 40, whereby that less or equal to 40 is referring to the entire line plus the space. Okay, and you want to really note that thing. It is referring to the entire line plus the space, all of that entire line plus the space here. That is what is referring to that. Now, we can go ahead and now do the second constraint now. What is the second constraint? The second constraint says that you have 4x1, okay, plus 3x2 less or equal to 120, or in this case, we'll make it 120. So you have 4x1 plus 3x2 equal to 120. We just take the limit. Okay. So if x2 is 0, what is x1? If x2 is 0, what is x1? And this is where I need you. I need you to be working along with me. If x2 is 0, x1 is 30. Fantastic. Okay. I'm getting some great guys helping me here. Okay. So x1 is 30. If x2 is 0, x1 is 30. And what if x1 is 0? If x1 is 0, if x1 is 0, x2 is what? X2 is 40. All right. So on the x1 axis, you can see that you have 30, okay? And then on the x2 axis, you have 40. So here you have 30, and 30 is going to be below 40. So you put it somewhere here and call it 30. And the 40 for the x2 is going to be above the 20. So let's put it somewhere here and call it 40. Now, the job you got to do is to join these two lines. That's what you want to do. Join these two lines. Okay, you join the 40 to the 30 like this. And so the space in question, okay, for this whole, number, that is the space in question. That is the space in question. That is the space in question. Okay. So on the basis of this, these are called the feasible solution area. Okay, the feasible solution area. Both the three spaces. And what are the three spaces? Well, you can see clearly that the three spaces. Let me just go back to this. Okay, the three spaces are one, this one, this one, and that one. Those are the three spaces. One of them is common to all of them, and that is known as the feasible solution area. Okay. Feasible solution area. And that feasible solution area, or a common solution area, that is going to be the number that you see here. Okay. So let's call this point A point, this point B point, and that point C point. So this area that you see here, that is a feasible solution area. Now listen here, this is where it gets interesting. This is where it gets interesting. Your job is to find the coordinates of all the vertices of this quadrilateral. Ha ha ha. You remember the good old days of A-level and SSS? You have to learn about quadrilaterals, a polygon, a hexagon. Now this is a quadrilateral. What is a quadrilateral there? The quadrilateral is from this section, A, all the way. Okay, I'm just going to use a different thing to show. Okay. You got to be able to have a feel. It is A to this point B, okay, and then B to this point C, okay, and then bounded by this distance up to the 0, followed by this distance up to the C. So you can see that space. That space has got vertices, okay? And the first vertex is the 0, so we don't want to deal with it. That point here, 0, 0. So that one is not too important. What is important are vertices A, B, and C. Your job, listen, your job is to find the coordinates of each of those vertices. And when you put those coordinates back to the Z function, where's the Z function? This is a Z function. When we put them back into the Z function, the one that will give you the highest profit, that coordinate is the optimal solution point. The one that will give you the highest profit is the optimal solution point. So in other words, I'm looking for Z value at the point of A. And I'm looking for Z value at the point of C. And I'm looking for Z value at the point of B. There's a reason why I put the B last. Okay, so let's go to A. Let's go to A. At the point of A, the coordinates are 0 for the x1, 20 for the x2. Okay, 0 for the x1. Someone says he can't see my screen. Do you all see my screen? I want to be sure. Do you all see my screen? Okay, so guy who says he can't see the screen, please log out and log back in. It's from your end. Okay, so let's go to A. We want to know the values of the Z, that is a profit, if we slot in the coordinates of A. And the coordinates of A are 0 and then 20. So let's drop it. Whatever we see X1, we'll put in 0. And whatever we see X2, we'll put in 20. You drop that into the Z value and tell me the answer. Who can tell me the answer for that? Okay. If you drop that into the Z value, what will be the answer? What will be the answer? Okay. Some of you have done it already. Fantastic. Okay. So the answer is going to be 1,000. 1,000. This one is between you, your God, and your calculator. Okay. You, your God, and a calculator. Now let's go to C. Let me do the C here. Z at the point of C, what is the value? Okay. Z at the point of C, what is the value? Now remember that C, when you check it carefully, C, the coordinates of C are 30 and 0. 30 for the X1, 0 for the X2. So 30 and 0. 30 and 0. So you put the 30, wherever you see the X1, you put the 0, wherever you see the X2. What is going to give you the Z value, the profit value at the point of C? What would be it? What would that be? Someone should type me the answer. Somebody should type me the answer. Equia, Felix, Samuel, Grace, okay? Give me some answers. Excellent. Theophania, Smith, Cyril. These are the names being mentioned into the kingdom. Okay, if your name is not mentioned, that's not good. Already do. Okay, that is a correct answer. So you're going to have a value which is equal to 1,002. Okay, 1,002. That is a profit. That is a value you're going to get. But now let's go to the point of B. Now, when you check the point of B very carefully, the point there is not simple to identify. Why? Because when you go to that point of B, to get a point, you need to get this line traced to the x-axis to get the x2 value, and then trace this one to the x-axis, the first one to the y-axis. Okay, trace this one to the x1 axis to get the value. Because you've not drawn to scale, you can't easily get a value. So you can use simultaneous equation to solve it. Why? Because these are two lines and the two lines are intersecting. Anytime two lines are intersecting, you can use equation or simultaneous equation to solve it. So that means that we need to go to these two, okay, these two numbers constraints here, and then go and handle them. Okay, go and handle these ones the way they're supposed to be. So I'm going to go back and then rewrite these two and solve it simultaneously. They are x1 plus 2x2. I'm going to use equal to as a gauge to just solve it quickly. That is equal to then 4x1 plus 3x2 equal to 120. Simultaneous equation simply will require you that using substitution method, you can call this equation 1 and you can call this equation 2. Hey, go and befriend your little sister and your little brother. Masa, and yet easy. You got to go to them and go tell them that, hey, I love you so much. I used to beat you up, but this is not a friendly time. This is a serious time. I beg you, I will buy you ice cream. This is the time I need you to help me with the Akiola mass. The simultaneous equation I've been seeing you doing plenty. Okay? If it is your child, go and actually beg your child to teach you Akiola. Okay. And to be honest, for me to teach you simultaneous equation is not a bad. So just get Akiola book and just solve the first 50 questions on simultaneous equation. Okay. All right. So let's see how we'll do it. It is the way you learn how to do it that is more important than just showing the answers. So first thing is that you move this 2x to the right-hand side. That's what you do. Okay. You move the 2x from the left-hand side, okay, to the right-hand side. That's it. And you'll be left to the x1. So you have x1 equal to the 40 minus 2x2. Why it is minus, you know it already. Anytime something crosses the equal to sign, it turns to minus. Now this becomes your equation 3. And all you now have to do is to drop this 4. You see, it says that wherever you see x1, it is 40 minus 2x2. So go to your second equation, which is your equation 2, and wherever you see x1, drop that 40 minus 2x2 there. So what is the x1? Well, it is 40 into bracket the x1, and then plus 3x2 equal to 120. And what is supposed to be into the bracket? Well, it is that function in equation 3, which is 40 minus 2x2. Now, this is a factorized equation. So you got to, expand it. Expanding it means that you multiply the 40, 4 by the 40, and then 4 by the 2. Okay. When you do 4 times 40, that is going to give you 160. And when you do 4 times 2, that will give you 8x2. Then you add your plus 3x2 equal to 120. Now you group like terms, the good old days of grouping like terms. Now you can see that this is minus 8 plus 3 because they are all x2, x2. So that will give you minus 5x2. Then you go into the equal to sign. The equal to sign you have on the other side 120 minus 160. And because it's 120 minus 160, that will be minus 40. So you will have minus 5x2 equal to minus 40. Okay. Minus 5x2. I'm just going step by step for a reason. Equals to minus 40. Because they are all minus minus, you can kill the minus. And now you'll be left with 5x2 equal to 40. You divide both sides by 5. You divide both sides by 5. 5 cancels 5. X2 is equal to 8. That is 40 divided by 8. So that is the value of x2. So you have the value of x2 sitting down here. Now, remember your equation 3. Remember that equation 3. We can find x1 by dropping the value of x2 right here. By dropping the value of x2. So let's rewrite that equation 3. When you rewrite it, you're going to get x1 equal to 40 minus 2x2. But we know that x2 is 8. So drop in the 8. Okay. And that will give you 40 minus 16. 40 minus 16 will give you 24. Remember, x1 is fan yogo. Okay, so this is actually fan yogo. This is the decision variable for yogo. And x2 is fan choco, which is what you have up there. So this is actually choco. These are your decision variables. Okay. So now we know the coordinates. We know the coordinates of B. Now remember, this is not necessarily the answer. We just use it to find the coordinates of B. So now we know that the coordinates of B here are 24 for the x1 and then 8 for the x2. Ladies and gentlemen, do you remember what I told you? How do you know the one that gives you the optimum profit, the best profit? Well, all you got to do is to substitute. So we said that we found the Z at A to be 1,000. We found the Z at C to be 1,002. Now let's find the Z at B. Okay, so you're going to put the 24 under the x1 that you found. Okay, so it's going to be 40 times 24 plus 50 times the x2, which was what? 8. Okay, these are the numbers, they are 8. So 40 times 24 plus 50 times 8. This is where your calculator should be your friend. And that will be 1,360 Ghana cedis. So now we know the values, okay? We know the values of each one, how much profit you're going to get at each vertex. at each corner point. We know it. It is not just writing the answer, but you know it in total. You know in your heart of heart. You did it by yourself. You didn't wait for somebody. You didn't copy your OPL. You didn't copy. You decided to go along with me and you found it yourself. The knowledge was oozing out of you. Your entire molecular structures was having that 1360 inside of you already. And you got to follow the tip. Now, which one is going to be the optimal solution point? It is the one that gave us the highest profit. And that one is point B. So you can now come to your conclusion and then say that Farm Mill Ghana Limited, in order to produce a profit of 1,360 Ghana cedis, in order to generate that maximum profit, the highest profit of 1,360 Ghana cedis, it has to produce 24 sachets of fine yogo and 8 sachets of fine chocolate to maximize that profit. Now you are putting in numbers. This is your advice to management, because you give a managerial advice and you tell them that. And this is how you have to. If you can observe carefully, I didn't go through all the mambo jumbos regarding the ISO profit, shifting the ISO profit up and down and all of that. You see, I left all of that. I've made it quite simple for you to be able to identify the profit case of the company. Now, that is not to say that you couldn't have used that graph to do it. But the thing is that sometimes you are not only using the graph, but you are also using the mathematics alongside the graph to guide you. So the optimal solution point is there. That is there. And that one is also one of the vertices of the quadrilateral. And so it is within the feasible solution. It's within the feasible solution. Okay. Now, if you don't understand something here, you let me know. This is where you got to raise your hand if you don't understand something. Something didn't work out the way you want it. This is where you are. Other than that, let's move on. You have been able to find the profits. Okay, so you got some people with questions. Okay, so let me start with Obed. Obed, do you have a question? Yes, let's go.
Yes, Doc. Doc, thank you very much for explaining it excellently. But my question is based on the 3 kinds of constraints. Please, you touched on the second one being mixed constraints. Please, could you kindly explain that a little for me, please?
Okay, so I will talk about the mixed constraints in the next few ones we are going to do. So when we get there, I'll handle the mixed constraints, no problem at all. I never used a mixed constraint. It wasn't part of the constraint here. Here we had labor constraint, it's a resource. We had milk constraint, it's also a resource, not mix. I'll talk about mix when we go into the irregular types. Let's go to Melody. Melody, you have a question? Yeah.
Not a question, Doc, please. I actually sent you a message. I wanted you to slow down a bit for me so that I could grab it very well.
Well, I can tell you that I've been able to slow down significantly. So when normally you don't grab it that well, this is the time you ask me your not grabbing well questions. But then you have the video as well to go and look at it. So the video will also help you significantly. Okay, Vincent. Let's go to Vincent.
Doc, please, I wanted to find out for the simultaneous equation, doesn't matter the method we use.
No, it doesn't.
They want us to stick to this one.
Oh, no, anyone you're comfortable. Okay, anyone. All right. So let's move on. Let's move on because there are exciting things to detect from here. Somebody says, please, all of you who are new, okay, don't worry. If you are new, somebody says he's new, it means that he's missed the previous lecture and all of that. It doesn't matter at all. Just go watch the video once, twice. I guarantee you, by the time you watch the video 3 times, Okay, 3 times, just 3 times. Okay. You know how you drive from your workplace, your home to the workplace, and you spend about an hour in the traffic? Sometimes just play the thing in your ears. Or when you come home, 1 hour before you go to bed, use it to just listen to the video. Okay. Or 1 hour before you wake up earlier than that. And then use it to work. You get it. The only reason why a person might not get something like this is because he's not sat down at least for an hour to look at it. Okay. But it's not all the time you can get it all here. Not all of you will understand all of it here today. It doesn't happen. I don't know how that should happen anyway. Because this has taken people time to write a book. So take your time. Not all of, most of you will understand it, but not all of it. I mean, most of you will understand it immediately, but not all of you will understand it immediately. But all of you will understand it eventually. All right. Now, let me rewrite the function for you. The function we have been dealing with is Z max, okay, equal to 40x1 plus 50x2. Okay. And this was subject to x1 plus 2x2, okay, less or equal to 40. And then 4x1 plus 3x2 less or equal to 120 gallons. And then you have your non-negativity constraint. Okay, this is what we've been dealing with all these while. And this is known as a non-standard form. The non-standard form. Non-standard. It's not the standard one. It's a non-standard form. So now, one of the things you got to learn is to convert it to the standard form. Okay? You learn how to convert the non-standard form to the standard form. Now, write this down. These are the 4 things that will happen if you are converting the linear programming problem, LPP, linear programming problem, from the non-standard to the standard form. 1. Okay, the first one is that you will add the slacks. You will add the slacks to the objective function as zeros. You add the slacks to the objective function as zeros. But before we move on, let me just quickly explain the slacks. The slacks in any company, in any organization, in Farmer Ghana Limited, are those resources that should have been used, but were not used. By the end of the production process, those resources were not used. Take, for example, a resource like labor hours. How many hours do you go to work and spend time in the workplace? It's 8 hours. Now, suppose you were to use 8 hours to do some work, but you didn't do that. You got to the workplace at 10 o'clock. It means that 2 hours is already gone. You started reading the newspapers. It's 12 o'clock. 4 hours is already gone. So now you have wasted some hours. That is called slacks. So the slack is an unused resource. Another name is that a slack is a wasted resource. It can be wasted time, it can be wasted material, it can be wasted anything. And in the government sectors, in the government standard and the private sectors, now, it doesn't mean that the private sectors don't generate slack, but the government sectors generate a lot of slacks. There are a lot of slacks in the government sector, a lot of wastages. People are sitting down watching Cantata and Kukumbaja when it is 3 p.m. instead of them actually doing some work. So slacks is said to be the inefficiencies. Put that down. They are wastages, they are unused resources, inefficiencies generated in the company. And so every resource will bring about a slack. The slack can be 0. That means that all the resources were fully utilized. Or the slack can be positive, not 0. Ouch, that is not good. Because once you have slacks, it means that some resources have been underutilized or they have not been used. And that is bad for any government, any company, any organization. The problem in most countries and in most businesses is that they don't calculate the slacks. And so they are abundant. For example, a company can be said to be the best bank in the country, the best bank in the banking industry, when in fact, so many hours were not utilized in generating the revenue or the deposit mobilization that was supposed to have been done. So slacks are the unused resources. Slacks are the inefficiencies. And you have to take your time to quantify it, else you are doomed as a company. So most of you in the businesses, tell your bosses. Some of you, by learning this course, you'll be able to advise management on slacks. Now, once you are supposed to use those resources and you don't use them, listen here. Once you are supposed to use the slacks and you don't use them, they are gone. You can't come back the next day and say, boss, please, yesterday I spent 6 hours in traffic. I couldn't get to the office early. And so I want to spend 6 hours. I mean, you really even want to do that. So the slacks, they don't add anything to the profit. That is why in the objective function, the slacks are 0. I normally ask you this question in an exam. So if you don't understand, you got to raise your hand. In the objective function, which is the profit function or the objective, the slacks contribute nothing to the objective function. Why? Because the slacks are unused. And once they are unused, they are gone. Once they are gone, they are gone. And there are so many. Once you have been inefficient on the job, you have been inefficient on the job. Even if you come the next day to come and do that work, you wasted the previous one, it's gone. And so the value of the slacks in the objective function are 0. Let me write that for you to see. So if this is objective function Z max, okay, which is equal to 40x1 plus 50x2, we are going to add the slacks. But listen, the slacks are given a name. The number of constraints, and that's my next point before I come and add that, okay? The number of constraints, that you have, excluding the non-negativity constraint, okay? The number of constraints will equal the number of slacks, okay? The number of slacks you need to have. So excluding the non-negativity constraint, guys, who can tell me the number of constraints we have here? Who can type it? What is the number of constraints we have? We have 2. Good. You have been very participatory. I like that. Okay. So that's 2. So how many slacks do you think we need to have in this model? How many slacks do you think we need to have? The same thing, 2. Okay. So we need to have 2 slacks. The name of the slack is given the letter S. So the first slack is called S1. The second slack is called S2. The third slack is called S3, and then on and on. And because in the objective function, we have already said the slacks are attached with 0. So you will write the slacks as plus 0 S1 plus 0 S2. That is how you introduce the slacks in the objective function. Now your question might be, why 0? Because we've said that the slacks contribute nothing. That's what Americans would say. The British would say the slacks do not contribute anything to the objective function or to objective value. And because of that, they are given a value of 0. So that when you multiply the 0 by the S1, you still get 0, which means I contributed nothing. So when you are converting it from the standard form, the non-standard form to the standard form, that is what happens. The slacks are introduced as 0. Then you go to your subject to, which leads me to the third point. The third point is that the slacks are subtracted from the constraint. Each slack is subtracted from the constraint, the left-hand side of the constraint, okay? Each slack is subtracted. And I'm using the word subtracted because we are dealing with maximization, okay? It's subtracted from the left-hand side of the constraint. So what is the left-hand side of the constraint here? Well, the left-hand side of the constraint is what you are seeing here, this part there, and this part there, okay? And so in rewriting this, you're going to write x1 plus the 2x2, then you subtract the first slack, which is S1, and then you convert the inequality to equality, okay? And that is the last part of the rule, okay? The last part of the rule is that in the constraints, the slack converts the inequalities to equalities, okay? I don't write that, you should get that. In the constraints, the slacks, they convert the inequalities to what? To equalities. So I'm going to let one of you tell me how the standard form for the last constraint is going to be like. Who can raise their hand and tell me how would I have to write the standard form? Okay, so somebody says that I should go over the fourth point. So let me write the fourth point. Okay, the fourth point is that, okay, the slacks convert the inequalities to equalities. That's all. That's the fourth point. The third point was that each slack is subtracted from the left-hand side of the constraint. Each slack is subtracted from the left-hand side of the constraint. And the fourth point is that the slacks convert the inequalities to equalities. Now, who can tell me how I should write that constraint given the rules I've just said? How would you have written the second constraint? Okay, Parkofi Jr. said 4x1 plus 3x2 minus 0s2. I'm sorry, okay, you've lost it there. You've lost it there. Who can tell me? Who can tell me? How would you write that one? How do you write the constraint with the presence of the slack? Who can tell me? Who can tell me? Excellent, Linda. I like your answer. 4x1 plus 3x2 minus s2. That's the right answer. And I'm sure Samuel and Grace and James, all of you are cracking that code. Okay. So the slacks for that second one, if you're writing the standard form, it will be 4x1 plus 3x2 minus s2 before you bring equal to 120. Okay, that is how you, so what it means is that each constraint becomes, gets a slack. The number of constraints will equal the number of slacks. I've already said that. And each constraint will have a slack. When you are done, there's one more constraint you don't want to joke with. There's one more constraint, and that is a non-negativity. But this time, because of the slack, you have to add that. So that one more constraint is x1, comma, x2, comma, s1, comma, that is a slack one, s2, comma, greater or equal to 0. So that one is not equal to 0. That one is greater or equal to 0. So that last constraint is also the non-negativity constraint. But this time, the slacks have been added. The slacks have been included. So that is the standard form that we have been discussing all along, the standard form, the standard form. So next time I give you a certain equation, or I let you formulate a certain equation, I can also tell you that after formulating the equation, you should tell me the standard form Now, how are you going to tell me that? All you got to do is to follow those 4 steps I've given you. Okay. Ensure that the slacks are given a value of 0. But in the constraint, they are not given a value of 0. Okay. The reason is because in the constraint, remember, they are added to the usage as minus. They are added to the usage as minus. Okay. And so you don't have to include them in that. Now I'm going to trick you small to see. Now our job now is to calculate the slacks at each of the corner points. Okay. Do you remember the graph? Okay, the graph. Okay, good. Now you remember the corner point. We have point A. Okay, we have point A. We have point B. We have point C, and the point B was a point that gave us an optimal solution point. Now, the thing is this, and what I want you to learn a little bit here is that you should be able to calculate the slack at each of the corner points. Okay. The slacks contribute nothing to the objective function. We know that in the standard form, we know that. But what we are going to do is that we're going to calculate the slacks at each of the corner points. So let me just remind you of a few things. Okay. The corner point, now in order to calculate the slacks at each of the corner points, you have to remember the equation. Let me rewrite the equation all over again. Okay. The equation is 40x1 plus 50x2. I'm writing the original equation. Okay, subject to x1 plus 2x2 less or equal to 40. Then 4x1 plus 3x2 less or equal to 120. And then your x1, your x2. This is the non-standard form. Okay. Now, we want to know the coordinates. If you remember the coordinates for each of the points, okay, I remember them. What were the coordinates for A? Well, the coordinates for A were, you can remind me, it was 0 and then a certain number. I just want to be sure you are following. Okay, that is why sometimes I ask you. All right, 0 and 20. Somebody asked a question, let me see. It says, somebody said I should repeat the non-negativity. The non-negativity is x1, x2, s1, s2 greater or equal to 0. That's the non-negativity. Doesn't matter which constraint gets which slack. Yes, the first constraint should have the first slack. Again, that's the answer to your question. The first constraint must have the first slack. The second constraint must have the second slack. The third constraint must have the third slack. Okay. All right. So A is 0, 20. B was 24 and then 8. And then C was 30, 0. Let me share that's correct. Okay. So what I want you now to do is this. You are going to take A and then you drop A into the first constraint and into the second constraint. And then you tell me the slacks. I'm going to do for A, you do for B and C for me. So if I drop A point, the coordinates, into the first constraint, that is the labor constraint here, okay, and then the mel constraint, labor constraint. If I do that, okay, where x1 is 0 and x2, look at x2. Okay, so in this case, x2, I'm going to put in the 20 there. If I do that, then it will mean that you will have 2 times 20, and that will be equal to the right-hand side, isn't it? That will be equal to the right-hand side. So is there S1 will be equal to what? The slack there will be equal to what? For that constraint, labor, the slack, S1 will be what? 0. Excellent. Okay. So now X1 will be 0. What about S2? Okay. For that same, let's go to the mel constraint. Okay. So when you go to the mel constraint, you drop the same thing there. Okay. You drop the 0 to the 4x1, and then you drop the 20 to the 3x2. So it becomes 3 times 20. Okay. When you do that 3 times 20, the slack 2, the S2 will be equal to what? Let me see whether some of you are thinking. Thinking, faculty. Beautiful. So you will have 60 gallons of slacks. Okay. So the S2 will be 60 because it will be 120 minus the 60. Remember, you are dropping 20 here. You are dropping 20 here. So it will be 3 times 20, which is 60. So that 60 means that you have 60 more before you get to the 120. So there's a slack, there's a wastage, there's an inefficiency. There are unused milk, which is what? 60. So for point 1, A, you have slack of 0 for the S1, 60 for the S2. Now let's go to the coordinates of B. Okay, the coordinates of B, what is the slack S1 and what is the slack S2? And then the coordinates of C. Please, if you are ready, raise your hand. I just want to give a marks to somebody. Okay, coordinates of C. What will be the slack S1 and the slack S2? That is if you are working along without any copycatting. Teofania.
Yes, please. So for the B, labor is equal to 0, so it's equal to 40, so there is 0 slack. And then milk is also equal to 120 hours, so 0 slack for both labor and milk.
I'm just kidding, that is correct. Okay, so you have 0 here and you have 0 there. Excellent, very good. I've given you 2 marks for that. Bernice will work it out for you, so take note. Okay, you have 2 marks. Let's go to another person for the coordinates of C. For the coordinates of C, let me go to Abeku. Coordinates of C. Yes, Abeku.
Yes, so for C, we have the coordinates 30, 0. So for the first constraint, the slack will be 10. And the second one, the slack is 0.
Excellent, very good. That's also 2 marks for you there. So guys, you may be wondering and sitting down on your chair, and what is this? What kind of Hebrew? What kind of Hebrew and Latin are these people talking about? That I can't see. The whole thing sounds like Hebrew to me. Okay. And it is not about that. It is more about your capacity to understand what is happening. So let's go to, for example, the B. The B is simply a matter of drop wherever you see the value of X1 and X2, drop the 24 and 8. So if you put the 24 at X1 and you put the 8 at X2 in the first constraint, 24 plus 8, 8 here times 2 will be 16. So the 24 plus 16, that will be 40. And if it is 40, it means that the left-hand side is equal to the right-hand side. And ladies and gentlemen, we've been saying it. When the left-hand side equals the right-hand side, then the slacks is what? 0. It's always like that. Okay. Okay. But when you do that, and then the left-hand side is not the same as the right-hand side, then there is a slack there, and you have to find the value of the slack. So for example, if you look at C, the C values were 30. Okay. You have 30, and then you have 0. The 30 is for the X1. So wherever you see X1, you put 30 there. So let's go to the first constraint, the labor constraint. Wherever you see X1, you put 30 there. The X2 is 0, so you don't even look at it. So if this left one here is 30, that is not up to the 40. So if it is not up to the 40, there's a gap, and that gap is a slack. So there's a gap of what, 10. That is what my good friend said is 10. But let's go to the second constraint. Okay. Again, you put the 30 in the first one here. So you have 4 times 30. That's why the X2 is 0. So you have 4 times 30, and 4 times 30 is what? It's 120. So you have 120 on the left-hand side, and you have 120 on the right-hand side. So the slack will be what? The slack will be 0. And that is why he said the slack is 0. So the point is that you should be able to calculate slacks at all the vertices, at all the corner points, at all the coordinated points. You should be able to identify The slacks. So anytime you get a slack, calculate them. Calculate the slacks at the corner. Now there's something interesting in our work we've done today. Watch it. You will notice that the one that gave us the coordinate, the B point, that gave us the highest profit, it also gave us 0 slacks. What does that mean? What it means is that if the company should produce at the point B, they are going to be efficient. They are going to be efficient in that production. There's not going to be any wastages. There's not going to be any unused resource. All the resources are going to be fully utilized. And that is pure efficiency. And so that is why it makes sense for you to advise management to produce at the point of what? B, because that point will give them the best solution without even incurring any slack. Now, that is not to say that it's always going to be that, you know, anytime you produce at the optimal, you will not incur some slacks. Please note, sometimes you'll be producing at the optimal and still be incurring some slacks. Okay? But of course, you would want a situation that will give you the best, highest output. Okay? So when you're learning this, you don't just learn and say, I'm lost. Because when you say, I'm lost, it means that you are in a jungle. But you say, I do not understand this very aspect of why this and this is happening. That way, you have a prior knowledge to contest. See, knowledge begets knowledge. Knowledge commands knowledge. So there are some questions a person will ask me, and I know that that person cannot stand here now. The person can't stand here now. Why? Because the person needs to go and learn the very, very basics to be able to ask that very question. All right. So we have been able to do this standard form and all of that. Now, let me show you something. I'm now showing you something in your slide. Okay. Just look at the slide. So in your slide, you will see that I've done the conversion, okay, of all the fun you got. And at each point, you will see the slacks there. You will know whether the slacks are what it is or the slacks are not what it is. Now, let me ask you a question and let me see who can give me the answer to this. Who can tell me the values of the slacks at the origin? Okay. What do you think will be the value of the slacks at the origin? Look at the picture there. At the origin, what will be the value of the slack? Who can raise their hand and tell me? If you can tell me that, it means you are fully with me. What is the value of the slacks at the origin? Vincent, Jason. Yeah,
Yes,
Vincent.
sir. It's for at the origin, S1 will be 40 and S2 will be 120.
Excellent. Why? Why did you give the answer?
That's because at the origin, we are not producing any fan yogo or fan choco. So there will be maximum wastage.
I like that. I like the word you use. There will be maximum wastage. Okay. So what it means is that you have not used any of the resources. So the unused resources are what is there. Okay. But that's very good. I'm giving you 2 marks for that. That intelligent answer. So at the origin, you have not used the resources anyway. So all the resources are unused. So if all the resources are unused, then the maximum number of resources will be the available resources. James, is your hand up? You have a question on that? You have a question related to that. So that is it at the origin.
I wanted to give the answer that database.
No problem. So you lower your hand once the answer is given. Okay. Because you can't give a double answer to an already given answer. I know you want maths. That is life. All right. So that, you see, your ability to understand these things is very good. Now, let me ask you something. As you look on the stage, as you look on the stage, I want you to educate me on something, you know, very, very tiny here. Now, if you look at the formulation very carefully, if you look at the formulation very carefully, you will notice something related to the production capacity. If I ask you just on the screen, okay, let me just move to another formulated. Okay. Just want to go to another formulated angle to ask you. Okay, so this is for the slack. Now, when you look on the screen, if I were to ask you, without finding the answers, okay, and I ask you that, what is the total number of gallons of milk that was used by this company? Which mathematics will reference that? What is the total gallons of milk that was used by this company? Who can tell me that? What is the total gallons of milk that was used by this company? If you look at it, used by this company, what is the total gallons of milk that was used by this company? Remember, the usage is the left-hand side of the equation. The available is the right-hand side of the equation. So if I'm asking you that gallons of milk, how many gallons of milk was used by this company? What would you say? Let me go to Irama. Irama, what answer do you have for the gallons of milk that was used by?
Okay, could it be less than or equal to 120 gallons?
Yes, but on the screen, just tell me what it will be. That's what I want. I want you to tell me, because you don't know the value yet. You don't know the value yet. But if I were to ask you, okay, you don't know the value. So what do you see in the story that would tell you the value? James, do you have something to give to us? What would that be?
I have, I'm a little bit confused. From the onset, when you were solving, you were subtracting the slugs from the left side of the equation. But here lies the slice is having, you are adding the slugs to the left side of the equation. It's more of like contradictory.
Was I subtracting?
Yes, please.
Oh,
you were subtracting. Okay, then that's fine. It rectifies. Okay. Yes. Thank you.
Okay. Yeah, that's a good point of notice. Yeah. Supposed to be subtracting, by the way. Let me go to the original so that you all see the original equation. Oh, so you were just saying that you weren't going to answer my question. Okay, so let's go to Kelvin to see whether Kelvin will be able to answer the question. Kelvin.
Yes, sir. So if we want to know the number of gallons that were used, it's 4x1 plus 3x2.
Exactly. Okay, assuming we don't know the value of the slugs. I just want to see if I can show you the entire equation. Okay, so this is the entire equation. Yes. Okay, so what if I ask you how many hours of labor was used to produce fan choco? What will represent that? How many hours of labor was used, just as you're looking at it on the screen, how many hours of labor was used to produce fan choco? Victoria, I like your answer, 2x2. Very good. How many gallons of milk was used to produce fan yogo? How many gallons of milk was used to produce fan yogo? Who can type me an answer there? How many gallons of milk was used to produce fan yogo? Excellent, Esther, please. Okay, that is 4x1. Okay, now listen. What was the total profit of Farmer Ghana Limited? What was the total profit of Farmer Ghana Limited? What was it? So this is before you even solved it. Okay. What was the total profit of Farmer Ghana Limited? What was the total profit? Total profit of Farmer Ghana Limited. All the answers I'm getting are wrong. I don't need a numerical answer. The right answer is from Linda and Victoria. 40x1 plus 50x2. That's the right answer. 40x1 plus. That's the total profit. Now, when you now know the values of the x1, you can substitute them. But now, as it is on the screen, that is the total. So how much profit was made in the production of choco? How much profit was made in the production of choco in this story? How much profit was made in the production of choco? It's 50x2. It's 50x2. It's 50x2. Your colleagues are doing it and you are not doing it. It means that you need to sit down and drink water and absorb the information at your own relaxed time. All right. So, ladies and gentlemen, your ability and your capacity to be able to decode these calculations is the first step, okay, in learning this. Now, this linear programming that we have done today, they are normal, they are regular. They are very regular. When I say they are very regular, somebody might not understand, but what do I mean by regular? Okay. Now, what it means is that you found one solution. You got the solution, first of all, and there was only one solution. If you can remember, one solution point we had was the point B, producing 24 units of fine yogo and 8 units of fine choco. Okay. So we had a value for it. But that, trust me, it's not all the time you have a value for it. It's not all the time. Yeah, some of the times you cannot get the value for it. Okay. Yeah, some of the times you will find multiple solutions. Okay, you find multiple solutions and they are calculation. Okay. And when you find such multiple solutions, it can be very, very confusing. How can you find multiple solutions? But you can. And so I'm going to show you something we are going to do next. Okay, next time, what we are going to be doing. We are going to be learning something known as the irregular types of linear programming model. Okay, let me show you. Okay, and we are going to do that next time. Irregular types of linear programming model. The first one will be the multiple optimal solution, infeasible solution, unbounded, and then redundancy. Okay. The multiple optimal linear programming, infeasibility, unboundedness, and redundancy. Now, they are not regular. They are kind of abnormal, kind of. And so we're going to study them and know how you can identify them and why they happen. Ladies and gentlemen, that brings us to the end of the entire caboodle.